Right, so let's get back on track after trying to prove your observer canonical form. So our on track is to find our L eventually. Alright, so therefore let's start. Alright, in order to find L, we're gonna find the Ackermann's method. Alright, using the Ackermann's method of the observable system. Okay, so over here we break this into three parts. This whole thing is the Ackermann's method already. Okay, take note. Okay, so what you can do now over here is that for this part over here, the definitions of this is that standard, if you have a 2 times 2 system over here, you have a 1 times 2 system over here. Okay, and therefore the last value will always be 1. If you have a 3 times 3 system, for example, if it's 3 times 3, then you have 0, 0, 1. If it's 4 times 4, it's 0, 0, 0, 1. This value is always at the last one. Standard, I don't know why, just take it first. Okay, next we're gonna evaluate this rank of the O, observable rank. Alright, inverse. Okay, the observable rank is this. Okay, CO, COAO. Alright, it is recommended if you were to do in this manner. So if you were to transpose them, you will have COT and AOTCO over here. Alright, so C will bring over here, your A will become here. Okay, the positions is matters. Alright, because the C over here is a 1 times 2, your A is 2 times 2. If you transpose, this one will be 2 times 2, this one will be 2 times 1. Alright, so it really matters. But anyway, my purpose over here is to want you to know that your RO over here, please take note to transpose it to here first. Okay, because it is very important, because I do quite a pretty long time, and ended up I didn't get some answers that we want. Alright, but anyway, so my R over here is equals to this one. Alright, for an observable system. Alright, and then the last one over here is simply taking the understanding of your desired output first. Alright, your desired output at the output poles is S plus 50, S plus 60, if you still remember. Your closed loop post is this one. Alright, if you were to open up and elaborate this one, you have S squared plus 100S plus 3000. Alright, and therefore for such of a case that happens, this thing over here, alright, changes your this things, into what? Alright, you have A squared plus 110A plus 3000I. Okay, this is a standard way of writing things. Okay, however, please do take note that this is slightly different from the Ackermann's method of the controller one. This is not this case. Alright, it's because you have a AOT over here, a transpose. Okay, so previously in the Ackermann's method for the controller, where it's talking about KC, alright, this one is A only. Alright, and therefore you have all these things. So therefore, please do not be confused with observable Ackermann's method when it's in terms of transpose. Okay, so somehow I'm going to rewrite this as A observable transpose square, alright, and A observable transpose and 3000I. Okay, so with this sets, all the definitions for the Ackermann's method to find K is set. Alright, what can we do? And you may wonder, why do we find K? Because K is equals to, because KT is equals to LL. Alright, so in order to find K and then we transpose it, we'll get LL already. Okay, so therefore let's do it. A, straight away you know our definitions we told you already. It's just the last value is always 1, the rest above this is always 0. Okay, for B, we're gonna evaluate the rank of the observer using this transpose. So just simply sub in my C and my A. My C is what? My C is this one, but because it's transpose, so I have 1, 0. Alright, and AOCOT, alright, we'll just simply multiply lah. So this thing is only multiplied. Minus 7, minus 1. I mean minus 1, minus 7 and 1. Okay, and your rank O over here, this one is your C T, this one is your AT CT. Right, because we know that my COT is now 1, 0, and then this thing over here is minus 7, 1. So I'll put it all in the matrix is like this. Okay, just take a look and compare. It's pretty straightforward. Alright, and then if I were to inverse this thing, alright, I'm simply just alright, because there is 1 and 1 over here, it's very tough for me to explain for the inverse, so I'll just write a general equation, so next time in the future you will want to need it. Alright, so 1 over determinant, alright, and then this one will become d, a, and then this is minus c, this is minus b. Okay, so if I had to solve for the determinant for this case, alright, it's just 1 times 1 minus 7 times 0, which is still 1, because anything times 0 is 0. So I have a determinant of 1 over here. Okay, while the d is this one will switch to here, while this thing over here will switch to here. So they have a 1 over here. Then this thing over here is my minus b, because fs is b, so I gotta input my minus b over here. You get what I mean? So I'll just simply put in minus, yeah. So minus 7 I change to 7. Okay, so I have 1, 0, 7, 0. This thing over here is this one, your inverse. Okay, so this is the way to find your inverse if you happen that you forgot. So therefore we have solved for the next part. We have solved for this one already. So the last part over here, we're gonna elaborate this thing over here. Alright, you're gonna elaborate this thing over here. Alright, so what we're gonna do is that this thing over here is a, t, and a, t. Alright, if you take note, our a is what? Our AO is this one. Alright, if you were to transpose this, what you have is this one over here. Okay, but why do you take a transpose times a transpose? Alright, it's because of this. Because we want to elaborate this one. Okay, if I will just simply paste it here, okay, since I don't need that part anymore. So this thing over here is this thing. Or 110 multiplied by a0t is this thing. And then 3000i is simply this one. Okay, so I hope that you are pretty clear about this. We're just trying to evaluate this one. Okay, so therefore I'll just do up the matrix multiplication. Alright, I'll not go into details on how to do it. Alright, I'll assume that you know, because it's row times column. Alright, and then row times column for this one is equals to this one, and then row times column again is equals to this one, row times column again is equals to this one. You just work it out yourself. I'll not go into there. So this thing over here will become this thing over here will become this thing over here will become this. Add them all together, you have this. Okay, next I'll just put it all together. Alright, I'll just take this part. If you still remember, this part is the standard part 0, 1. Alright, I'll just copy and just paste it here. At least you get to know the stuff. Hold on, yeah. Let's paste it over here. And then the part B is for our rank inverse, right? We have evaluated already, which is this one, right? So therefore I'll just also bring it over here. Ta-da, you see? And then the last one is our third part, which is this one we have just elaborated. Okay, so therefore I'll just bring this over here. You see, it's the same thing, right? And therefore if you were to do up the matrices all again, taking note that please remember it's row times column, and then for this one, okay, I'm not going into details, but anyway, so eventually you'll get your k is equals to 103,298. Okay, and then if you were to because we know that L is equals to KT, then you have this thing over here. Alright, and you'll have a L. Ta-da! You may wonder what is the A, B, and C. Alright, these are the things that are just randomly assigned. Alright, this can be 1, 2, 3. This can be Aku, Balu, Kalu, whatever. Okay, it's whatever name that I want to name it, because I just want to show you that there's the Ackermann's method has 3 parts. The first part, the second part, and the third part. Alright, and you're gonna solve them eventually yeah, you're gonna solve them one by one. Alright. Therefore, this is it. And in the next video, we'll do a summarization to combine, the understandings of lesson 7 for all this lesson 7 with our lesson 8, all these things. There are some of the key concepts lah. I'll not go into details, but I'll just somewhat briefly go through the difference between them and the similarity between them, and things to take note, so that in the future, if you want to take a look, you just take a look in the summary, and then hopefully you can get some meaning to that. So yeah, see you in the next video then.